We are going to finish our look at vertex form for quadratic equations. Remember that vertex form is y equals a times quantity x minus h squared plus k, where h and k give the vertex of our quadratic graph. So let's take a look here at what we got. Caitlin has 60 feet of material that can be used to make a fence. Using this material, she wants to create a rectangular pen for her dogs to play in. What dimensions will maximize the area of the pen? So, let W be the width of the rectangular pen in feet. Write an expression that represents the length when the width is W feet. Okay, so we know that the perimeter here is going to be the perimeter of this shape is going to be all right, let me actually do this way. Let's do a rectangle here. So we'll say this is the width. This is the length, this is the length. So the perimeter is 2 width plus 2 lengths. Okay? Now we know the perimeter is going to be 60 feet. She has 60 feet of material to use for the fencing. So that's going to go around the outside, which would be the perimeter. All right. Then she wants to create a rectangular pen for her dogs to play in. What dimensions will maximize the area of the pen? So write an expression that represents the length when the width is W feet. So we're gonna solve this for L. So we'll subtract 2W on both sides. And I'm going to have to read it up here. So we'll have 2L equals 60 minus 2W, and then we'll just divide everything by 2. And we get 30 minus W. And there's our length expression in terms of W. Okay? For letter B, define a function A of W that describes the area in terms of the width. And you can know we're using the width here because we're using W for our independent variable. So the area of a rectangle, remember, is length times width, but we know what the length is, right? We just came up with this expression right here. So we can rewrite this as 30 minus W instead of the L times W. Okay? And now it asks us to rewrite this in vertex form. So let's go ahead and multiply this out. And we'll end up with A of W equals negative W squared plus 30W. Okay, and so to write this in vertex form then, we need to create a perfect square here, which is going to require that we use completing the square. Okay, so remember, for completing the square, I'm going to go ahead and factor out a -1 here, just to make these numbers a little bit easier to work with. Okay, I'm going to leave some space here too. We want to figure out how this should factor to create a perfect square. Right, so we know we will need a W and a W. We'll still have that -1 there too. Okay, and then these two numbers that go in here, right? This number will multiply with this W. This number here will multiply with this W, and they're going to add to make -30. Since we're also trying to create a perfect square, these two numbers not only need to add to make the 30, they also need to be the same number. So what two numbers that are the same add to make -30? The answer is -15. Okay, but of course we can't just bring in a -15. Oh, so -15, which means what number has to be here? What number do we need here? Well, the number that we need here is going to be the -15 times the -15, which is 225. We can't just add 225 from out of nowhere, right? We didn't have a 225 up here to bring down. We're just bringing it in. So we also will subtract a 225 as well, excuse me, to balance out the equation. Or balance out, so that way we're really just adding 0. So we still have the -225 right here. Okay, as a result then, we'll have that the area is equal to negative W minus 15 squared minus 225. So then what are the coordinates of the vertex? Well, you tell me. Look at that and tell me what the coordinates of the vertex are going to be. Remember, use your H and K idea from right here. Okay, the coordinates of the vertex are 15, comma, negative 225. Okay, In terms of the problem here, oh, wait a minute. I made an error here. I see what I did. When I add in this positive 225, right here, when I'm adding in 225, it's actually being multiplied with a negative 1, right? Because this 225 would multiply with negative 1. So the actual quantity that I'm adding in is a negative 225. So to balance that out, I actually need to subtract 225 outside here. Add 225. This positive 225 is actually multiplied with negative 1. It's really a negative 225. To make 0, then I need to add a 225 outside here. So that's the catch here. So this should really be plus 225. So that makes my vertex 15 comma positive 225. Okay? So interpret the vertex in terms of the problem. So remember that 15, right, that's our x-coordinate, but in this case the x is really the w. So 15 is the width of the pen, and so then the length would be equal to, well, what did we say the length was? The length is 30 minus w. So the L is 30 minus 15, which is also 15. Okay, so in other words, the shape that maximizes the area while minimizing the amount of fence that we use is going to be a square. Okay, and so then what's 225? Well, 225, remember that's the y value here, which is the area when the width is 15. So the area of the pen is 225, and I think it's feet. Yep, feet squared. This is feet. This is also feet. Oh, so there you go. What dimensions maximize the area of the pen? Do you think it's a surprising answer? So again, what maximizes it is the 15s there. Do you think it's surprising? No. Okay, no. A square is, a shape that, well, I can't even make a good explanation for this. I mean, truly, you're going to find that the more you do these kinds of problems, that the square, if you have like a certain amount of fencing that you want to limit to yourself to using, that a square is going to be the ideal shape to cover the most amount of area. Okay, so don't really have a good explanation other than that. But most importantly, summary here, when graphing a quadratic equation in vertex form, where we have the a times x minus h squared plus k, h and k, right, are the coordinates of the vertex. All right, thanks guys, and we'll see you next lesson.